In this video, we're going to talk about how to write the equation of a parabola given 3 points. So remember, we talked about standard form and how you can identify key characteristics of a parabola from its equation in standard form. The y-intercept is at 0c, the x-coordinate of the vertex is at negative b over 2a, which also helps us find the equation of the axis of symmetry. So we can write equations of parabolas in standard form if we're given 3 points on the parabola. And there's actually 3 methods we can use to do this. We can write a system of equations and solve it algebraically. We can write a system of equations and solve it using matrices, or we can use quadratic regressions, which you've already studied. So the first method we'll talk about is how to set up a 3 by 3 system and solve it algebraically. So remember, these are our steps. So we're going to write our equations and decide on a variable to eliminate. Then we'll combine 2 different pairs of equations to eliminate this variable and then solve the resulting 2 by 2 system. We'll substitute the values we found back into one of the original equations to figure out the value of the variable that we eliminated, and then use the values of a, b, and c to write the quadratic equation in standard form. So let's practice with this example. Let's write the equation of the quadratic function that passes through the points -2, 22, 1, 7, and 4, 10. So the thing to realize here is that each of these points gives us an x and y value. Okay, so this is x and y. So what I can do is I can plug into standard form, which is y equals ax squared plus bx plus c. So if I plug this first point into this equation, I get 22 equals a times -2 squared plus b times -2 plus c. So all I need to do now is simplify this. So I have 22 equals, well, -2 squared is 4, so I have 4a. -2 times b is -2b, and then I have plus c. So remember, whenever we're solving systems, we like to number our equations. So I'm going to go ahead and call this equation number 1. Now let's repeat this process with the second point. So we have 1, 7, which gives me an x and y value. So I'm going to plug into standard form. So that's going to give me 7 equals a times 1 squared plus b times 1 plus c. So I have 7 equals 1 squared times a. Well, that's 1a, so I'm just going to write that as a, plus 1b, which is just b, and then plus c. Okay, so I'm going to call that equation number 2. And then I'm going to write the next equation based on 4, 10. So that's my x and y value. So I have 10 equals a times 4 squared plus b times 4 plus c. So I have 10 equals 4 squared is 16. So I have 16a plus 4b plus c. Okay, and that's going to be equation number 3. So now I need to strategically combine these 3 equations so that I can solve for my variables. So just for reference, I'm going to write out all 3 of these equations. So we have 4a minus 2b plus c equals 22. And I just flip that equation so that the solution will be on the right. Then I have equation 2, which is a plus b plus c equals 7. And equation 3, which is 16a plus 4b plus c equals 10. So if we look at all 3 of these equations, remember we need to decide which variable we're going to eliminate. So I notice that every equation has a c in it, so I'm going to try to eliminate c. So what I'm going to do now is compare these equations 2 at a time and then put them together so that I can cancel out c. All right, so let's first try to combine 1 and 2. Okay, so the first 2 equations. So I have 4a minus 2b plus c equals 22, and then a plus b plus c equals 7. So to cancel c, I'm going to multiply the bottom equation by -1. So that gives me -a minus b minus c equals -7. And then I'm going to recopy my first equation so that I can just put them together. So when I do that, I get 4a minus a, so that gives me 3a, -2b minus b, which gives me -3b, and then I have 22 minus 7, which is 15. So I'm going to go ahead and call that equation number 4. Now let's combine equation 1 and equation 3. So equation 1 is 4a minus 2b plus c equals 22, and equation number 3 is 16a plus 4b plus c equals 10. So I'm going to multiply the bottom equation by -1. So that gives me -16a minus 4b minus c equals -10. I'm going to combine that with my top equation, which is 4a minus 2b plus c equals 22. So now let's go ahead and combine these equations. So 4a minus 16a gives me negative 12a. Negative 2b minus 4b is minus 6b, and then plus c and minus c just cancel each other out. Then we have 22 minus 10, which is equal to 12. So this is now equation number 5. So if we try to combine equation 4 and equation 5, well, let's see what we have here. We have 3a minus 3b equals 15, and we have negative 12a minus 6b equals 12. So when I combine these two equations together, I can try to cancel out that 3a term. So to do that, I'm going to multiply the top equation by 4. So I have 12a minus 12b equals 60. And then I'm just going to recopy my second equation, negative 12a minus 6b equals 12. So when I combine these equations together, the 12a and minus 12a cancel, and then we have negative 12b minus 6b, which is negative 18b, equals 60 plus 12, which is 72. So when we have negative 18b equals 72, we can divide both sides by negative 18, and that is going to give us b equals negative 4. So now that we have the value of b, let's use b to figure out the value of the other variables. So I'm going to use equation 4 to do this. So equation 4 is 3a minus 3 times b. So I know that b is negative 4, and that's equal to 15. So I have 3a minus 3 times negative 4, which is negative 12. Minus negative becomes plus, so I have that's equal to 15. Now to solve for a, I just need to subtract 12 from both sides. And when I do that, I get 3a equals 3, and I can divide both sides by 3 to get a equals 1. So now I have a and b, and I need to find c. So I'm going to go back, and I'm going to use this equation number 2. So I have a plus b plus c equals 7. So equation 2 is going to be 1 plus negative 4 plus c is equal to 7. 1 plus negative 4 is negative 3, so I have negative 3 plus c equals 7. So it can solve this by adding 3 to both sides, and when I do that, I get c equals 10. So let's plug everything back into y equals ax squared plus bx plus c, right? That's what we were solving for. So we have y equals 1x squared minus 4x plus 10. Remember, we usually don't write coefficients of 1, so I'm just going to write y equals x squared minus 4x plus 10. And so all of that work that we did was to figure out this quadratic equation right here. So another way to do this in what we talked about is to solve a system using technology with matrices. Remember that you can use this in Desmos or in your TI calculator. Okay, so I'm just going to do this in the TI because that's what I usually use. But if you want to use the Desmos matrix calculator, I've included those instructions also. So we're going to start off with the same process as before. We're going to set up a system of equations, but we're going to solve it a little bit differently. So I'm going to take the 3 points that are given on this parabola and use them to set up a new system of equations. So my first point is 0, 5. So when I plug that in, I get 5 equals a times 0 squared plus b times 0 plus c. So that basically tells me that 5 equals c. Now my next point is going to be 4, 5. So that's going to give me the equation 5 equals a times 4 squared plus b times 4 plus c. So if I simplify this, I get 5 equals 16a plus 4b plus c. And then finally, my third point, I have 2, 1. So that's going to give me 1 equals a times 2 squared plus b times 2 plus c. So that gives me 1 equals a times 2 squared is going to be 4a plus 2b plus c. So I have equation 1, equation 2, and equation 3. Okay, so now I'm going to rearrange these equations a little bit because remember, I need my equations to be in standard form when I'm setting up my matrix. So for example, this 5 equals c, I'm going to rewrite that equation 1 as 0a plus 0b plus 1c is equal to 5. Okay, and the reason I did that is because we need to account for those a and b terms, and so since they're not there, we just put them in as 0 terms. Also remember, when we're going to set up the matrix, it's helpful to remember we have that coefficient of 1 in front of c. Okay, so now for equation 2. So equation 2, I'm going to rearrange. So I have now 16a plus 4b plus 1c is equal to 5. All I really did here was flip the equation and add in this coefficient of 1. Now let's do equation 3. So equation 3 was 1 equals 4a plus 2b plus c. So I'm just going to rewrite that as 4a plus 2b plus 1c is equal to 1. Okay, so now we have our equations in standard form, so we can set up our augmented matrix. So row 1 is going to be 0, 0, 1, and then 5. Remember, I put this line here for my solutions. And then row 2 is going to be 16, 4, 1, and then 5. And then row 3 will be 4, 2, 1, and then 1. Okay, so I'm going to use reduced row echelon form to solve this. If you want, you can use Kramer's rule, but I just decided to use reduced row echelon form because I think it's quicker. Remember that this is a 3 by 4 matrix, so I'm going to go ahead and go to second matrix, arrow over to edit. So this is set up to be 3 by 3, so I'm just going to adjust that, so 3 by 4, and then I enter my values. So I have 0, 0, 1, and 5. And then I have 16, 4, 1, and 5, 4, 2, 1, and 1. Okay, so just remember to scroll back and make sure that everything looks correct. And then I'm going to do second quit. And then remember, I go to second matrix, and then I go to math. I need to scroll down to reduce row echelon form. That is option B. And then I need to remember the matrix that I just entered. So second matrix, and then I tell it to remember matrix A. And then when I hit enter, remember the final column will give me the solutions. So this is telling me that A equals 1, B equals -4, and C equals 5. So I'm going to plug that into standard form, which is y equals ax squared plus bx plus c. So I have y equals 1x squared minus 4x plus 5. Remember that 1 I can drop, so I have y equals x squared minus 4x plus 5. So that is the quadratic equation that represents that graph that we saw in the original question. Okay, so now method number 3. So method 3 is also a calculator method. We can use regressions on the calculator. And I know you did learn about regressions back in Algebra 1. Remember that you can do regressions in Desmos or in your TI. I'll actually show you both methods since we haven't reviewed those in a little bit. So let's use regressions to formulate a quadratic function that represents the points in this table. So actually what you need when you're doing regressions is a table because you're going to, if you're in your calculator, you're going to call this left side L1 and this right side L2. Okay, so X is going to be L1, Y is going to be L2. So I'll first show you in the TI. So you go to Stat and then hit enter on edit. If you have anything written here, you just arrow up until the title is highlighted, click clear, and then enter. Okay, but mine is already clear, so I just enter these values. So I do L1, so I have 0, 3, -3, and then arrow over to L2, we do -6, 0, and 6. Always remember to double check and make sure that your values are entered correctly. And then we go to Stat, and then arrow to calculate. Okay, in calculate, you need to find quad reg, which is option 5, and then hit enter. Keep hitting enter until calculate is highlighted. Hit enter again, and then it gives you the values of A, B, and C. So here we can see that A is 1, B is -1, and C is -6. So when we plug into our equation, we get y equals 1x squared minus 1x minus 6. So I usually don't write those coefficients of 1, so I just write y equals x squared minus x minus 6. Okay, and that's the quadratic equation that represents those points in the table. But I said I would show you in Desmos, so let's go to Desmos now. What you will do is you'll create the table by going to this plus sign. It says add item, and you're going to select table. So in X1, you're going to enter all of these X values. So we have say 0, 3, -3. And then in Y1, we enter all of our Y values. So we have -6, 0, and 6. Okay, so now we need to tell it standard form of the quadratic function. Okay, so that's how we tell it a quadratic regression. So we type y1, and the reason we do that is because we're telling it to use these y values. Okay, we're not just saying any y, we're saying please use these y's. And then we use this tilde symbol. So that's the way we say please approximate a quadratic. And then we tell it standard form of a quadratic. So ax1 squared, right? We're basically typing ax squared plus bx plus c, but we have to use x1 because that is the x values that we're talking about. So ax1 squared plus bx1 plus c. Okay, and now you can see here under parameters, it gives us a equals 1, b equals -1, and c equals -6. The same values that the TI calculator told us. We just plug those into standard form, and that's how we write the equation. So now you can go ahead and pause the video and use your favorite method of the three we discussed to figure out the quadratic function that's represented in this graph. So if you want to, you can set up a system of equations and solve it algebraically. So you can use each of the 3 points given on the graph to set up your system of equations, and then you can combine the system of equations to figure out each of the variables. So this is how I went ahead and solved this problem. You can see that I combined equation 2 and 3 because you have equation 2 that's already solved for a variable. So it actually makes it a little bit quicker in this problem because you can just plug in that -5 to equation 3. And so that gives you an equation in 2 variables. I used the same strategy with equation 1. I plugged in -5 for c, and then I had an equation in 2 variables. Then I combined 4 and 5, and I decided to go ahead and multiply the top equation by 2 to cancel out b. So when I solved this, I ended up with a equals 1. A equals 1, I plugged back in and found b equals 3. I didn't need to solve for c because the second equation was already solved for c. So that gave me the quadratic function y equals x squared plus 3x minus 5. You could have chosen to do this using technology with matrices. So once again, you have to set up the system of equations, but remember now when you're using matrices, your equations have to be in standard form. So here are the equations in standard form, and here's the augmented matrix that I set up. I then went to my calculator, and that's where I used reduced row echelon form of this matrix that I entered here to figure out the values of a, b, and c, which are 1, 3, and -5. So when you plug that into standard form, you get the same quadratic that we found just a minute ago. We have y equals x squared plus 3x minus 5. The third method you could have done is regressions on the calculator. So I did this regression in Desmos. I created the table, by typing in all of my points. And then I typed in y1 is approximately ax1 squared plus bx1 plus c. So in parameters, you can see that it gave me a is 1, b is 3, and c is -5. And when you plug into standard form, you get y equals x squared plus 3x minus 5. So given 3 points on a parabola, you can actually write the equation of the corresponding quadratic function. You can write and solve a system of equations algebraically or using technology with matrices. You can also use a quadratic regression on the calculator to write the equation.